We're going to continue with Unit 4, and I want you to go ahead and get your learning target and go ahead and title Unit 4 Unit Linear Functions as well so that you know you're starting your new unit here. Today, our target is I can calculate the average rate of change of a function presented in a graph or as a table. So you may have heard of average rate of change before. And perhaps you have called it this before. So you should have studied slope before algebra. And also in the sequences that you just did at the very end of Unit 3, the common difference in an arithmetic sequence is also going to turn out to be the slope. So the average rate of change, the slope, the common difference are all really talking about the same thing. Just depends on the scenario and the exact type of question that you are being asked. So we're going to start off with Sia and her love of chandeliers. Sia is decorating a huge mansion. She started with 5 chandeliers and bought a consistent amount each month. Below, you'll find a table that represents how many chandeliers Sia owned each month. So look at this table, 0 months. That means she had 5 chandeliers in her house to start with. After 1 month, she had 8. So I notice that she added 3. In the second month, she had 11. So I noticed that she added 3 again. So you'll notice the way I'm doing this, it looks like the way we found the common difference. 14 adding 3 to get 17, and 17 adding 3 to get 20. So I'm going to come on down here and I'm going to look at question A. Predict how many chandeliers Sia will have in month 6. Well, I'm pretty sure if I add 3 more, she's going to have 23 chandeliers after 6 months. And then it says, describe your method for the above prediction. I'm just going to say added 3 each month. So her rate of change was actually 3. She was changing the amount of chandeliers she had by 3 each month. Now let's go over here and look at this graph. What is this graph doing here? Well, on this graph, I can actually plot the points. So at 0 months, she had 5. And after 1 month, she was already up to 8 chandeliers. And after 2 months, she had 11. And after 3 months, she had 14. And after 4 months, we were up to 17. And after 5 months, up to 20. Now I can draw a line through this. And you'll see that if my line is pretty straight, that 6 months could use the line to predict, but we're putting this all together. We've got our common difference, which is the rate of change. She added 3 each month. If we put it on a graph, it makes a line. So all of this goes together into our unit linear functions. Let's look at this example. Oh no. Sia went bankrupt when they realized she copyrighted one of her new songs. The IRS came in and confiscated a consistent amount of chandeliers from Sia each month. The table below represents how many chandeliers were in Sia's mansion each month. So, using this table, predict how many chandeliers Sia will have in month 6. You can also take this information and put it on the graph. So, before the IRS came in, 0 time had passed. She was already up to 45 chandeliers. After 1 month, she was down to 40. After 2 months, 3 months, 30, 4 months, 25, 5 months, 20. And so you'll see that the graph that I've pre-drawn on here ends. Eventually she will get down to 0 chandeliers, and she cannot go below 0 chandeliers. So the end of this would be 0. The rate of change for this scenario is 5 taken away each month. Hopefully you figured out that this constant difference was -5. So this is an arithmetic sequence. It is changing by the same amount each time. We call this the rate of change. We might call it the slope in this line. We might call it the constant difference in this arithmetic sequence. Okay, so getting away from the scenarios, but still going along the same idea, I'm going to take these points and I'm going to plot them on the graph. So remember, the first point is x, the second point is y. So I'm going to go on to x, -1, and then I'm going to go down to -2 and plot this point. And for 0, 1, I'm going to stay at 0 on x and go down to -1. And for 1, 0, I'm going to go to 1 on x, but move 0. Now, can you tell me what would be the next point going up to the right? What is the fourth point going up and to the right? Look closely at the graph and then choose the correct ordered pair. So hopefully you determined that the next point should be 2, 1. I hope that you got that by noticing that it was up 1 over 1, up 1 over 1. So you go up 1 over 1 to the next point. You can also use your table to look at that pattern. So I'm going to put my points. -1, -2 is the first point. 0, -1 was the second point. 1, 0 was the third point. These are the points that were first given. And then the point that I added was 2, 1. What you notice is that the x's are going up by 1 and the y's are going up by 1. So that's what I ended up doing on the graph. I went up 1 over 1 each time. Up 1 over 1, up 1 over 1. Y, of course, is the up or down, and x is the right or left. So in my picture, I was going up and right. So let's look at another one of these. Here's another one. So I want to first plot the points. Like I'm plotting my points, and it looks like I'm coming down. So the question is, what is the fourth point? So I want you to look closely at this graph and see if you can say, what will the coordinates be of the next point? Okay, hopefully on a close inspection, you determined that this would be your next point, and that point is in line with 1 on x and -3 on y. The method for finding the point. How did you do it? So I hope that you did it by going down 2 over 1, down 2 over 1, down 2 over 1, and then down 2 over 1. So the method, down 2 over 1. You'll see that pattern here again, and I'm going to take these points and fill them in the table along with my last point. I'm going to fill in the table. Okay, so looking at the table, you can see what's happening to my x values. They are going up 1, but my y values are going down 2. So remember on the graph, I went down 2 over 1, down 2 over 1. That's what this -2 would represent, and this +1 represents going to the right. So I went down and I went right. Notice that we are always going to talk about up or down first, or I have so far, and that's what I want you to do. I want you to talk about how much you go up or down first, and then how much you go to the right. So I want you to take some time to copy this down, and then we are going to focus on today based on the examples that I've already just given you. Today, we're going to focus on this part, rise over run. Rise is the up or down part, and run is the right. Go ahead and copy this entire formula. Rate of change is represented by the letter M. You've probably heard of y equals mx plus b. It stands for the slope. Rate of change and slope are the same thing. And the formula we're about to practice on is rise over run. So let's take a look at this first picture. And what I want to do is I'm going to use my line tool to make a right angle between the 2 points. So between these 2 points, this is the picture that I get. And from the formula that you wrote down that we are looking for rise over run, rise over run. The rise is the up or down part, and the run, we want to be talking about which way we go to the right. So in this scenario, from left to right, it looks like between the 2 dots, my rise is 1 and my run is to the right 2. So the slope, according to this picture, is 1/2. All right, let's talk about that again. I want to measure between those 2 points that are clearly marked. And this time it made a right angle above. And again, I want to check the rise between the two, but I notice that in this scenario, going from left to right, that I'm going to end up having to go down. And the amount I'm going down is 1, 2, 3, 4, 5. So that's going to be represented by a -5. And the amount to the right is 1, 2, 3, 4. So in this picture, my slope is -5/4. Rise is always going to be counted first, and run will be counted second. So now let's look at this one. On this one, I have no rise. So for my rise, since there is no rise, I could put 0 on top, and then there's 1 space between these two, 0 over 1, but this equals 0, and we don't really want to leave a fraction with 0 in it. So we're going to say for a horizontal line, there is 0 slope or no slope. Horizontal line, 0 slope. Okay, here's another one. We're going to check the right angle between these 2 points. And from my right angle, from this point to this point, I will be going from left to right. It's very slight, but from left to right, I am going up. So I'm going to count up 1, 2, 3, 4. So my rise is 4. And my run is only over 1. I'm going up, so they're both positive. And you can change this to say that the slope is 4. On the next example, I'm going to make that right angle again. And I notice from left to right that I'm going down. So that means my rise will be negative. And I just need to see how much it is. 1, 2, 3, 4. So I'm going down. It's -4. And my run is 2. And guys, this can be simplified to -2 for my slope. Now let's look at this one. This one has a rise of 2, but it has no run. It does not move left or right. So 0. And this is something that you may not have seen before. I need you to mark it down and not forget it. If you have 0 in the denominator, otherwise it looks like you are supposed to divide by 0, you stop and you write a word. And the word that you write is undefined. Division by 0 is undefined, and so we say that the slope of this line is undefined. Okay, so you guys are going to do delta math next, and you're going to be finding slope like I was just doing on the video. But when I was doing it on the video, I was able to use my smartboard tools, and I was able to make a picture for the slope that I could count. And so I was counting rise and run using this tool. You guys will not have this tool, but Delta Math does have something built in that you can use, and I'm going to show that to you. Make sure you're paying attention because it takes more steps than my smartboard tool. So just watch what I'm doing. Twice to plot each segment. So instead of one right angle, you're going to have to do 2 parts of it. And you're going to, if you do something wrong, you're going to click a segment to delete it. So first of all, what I want you to see, and depending on the lighting in the room you're in and the settings of your computer, you might not notice that there's a little pink dot following my mouse around. And the pink dot is only falling on grid lines. It's not falling in between. So what I did just now is I clicked 2 corners of the grid and it made this little line. Well, that's obviously not where I want it because that's not the rise or run for my line. So to get rid of it, I just click on the segment and it removes the segment. So I'm going to come down to my line and I need this little pink dot to be somewhere on my line. So notice right here, I can't get it to land on my line. So I'm going to move over. I'm going to click right there. And I'm going to come over to, let's say I come here, because what I'm noticing is down here is another spot that I can make a point. So I just had to click to get all of those lines to make my right angle. I had to do the clicks, 2 clicks to make this line and 2 clicks to make this line. Now it's asking me for the slope of the line. The slope of the line is the rise, which is 1, 2, 3. So the rise is 3. And the run is 1, 2, 3, 4, 5, 6. So I will have a rise of 3 and a run of 6. Now, I don't want to leave 3 over 6 because that is a fraction that I recognize can be reduced to 1/2. So when I get ready to put that answer in the box right here, I'm going to type in 1/2. It automatically changes it to a fraction for me. Now I'm going to click submit for my answer. And as usual, it's going to ask me if I feel like that is the correct answer. And I'm going to say yes. And it tells me that I'm right. You'll notice if I check, they drew a line in a different place than I did, and they got 1/2 on their first try. They didn't have to simplify it. All right, let's try one more just to remind you how you need to click. I want to find somewhere that this line actually crosses the grid where my pink dot will land on it. So my pink dot will land here, and it looks like it'll land here. So I want to go across from that. So that's going to be my rise. And then I also have to draw the line for the run. So I have my 2 lines drawn that make the right angle. And then to count that slope, I'm going to say what the rise is: 1, 2, 3, 4. So the rise is 4. And the run is 1, 2, 3. But remember, this is actually going down from left to right. So I'm going to count this as a -4. When I get ready to type it in, I'm going to say -4. I'm using the slash mark, which you guys can't see, but I'm just using the /. Once again, you notice they drew their line in a different place, but they still have this line going down. So they also have for the rise that it's -4 and the run is 3. And so it's time for you to practice.